ignite, but the heat drives off most elements except for carbon. Thus it carbonizes or coalifies the material. The brief hot heat will give you high-quality coal. Low-grade heat over a longer time will give you the lower-grade brown-type coal, but it certainly doesn't take millions of years. We also found many of these logs that begin to float upright after a while. Even though they're dead, they can absorb water from the root end and have buoyancy at the top and be heavier at the bottom. And with their scuba diving, they found a lot of these on the bottom of the lake. In fact, when they towed the sonar fish, they had found up to 20,000, they estimate, on the bottom of the lake. A whole forest there. It didn't grow there. It was catastrophically transported there, sunk down, got buried in the bottom, much like we have at Specimen Ridge in Yellowstone Park. But you'd see this all over the world at the time of the flood. Forests being ripped off, the branches being broken off, and then these things eventually coming to rest in an upright position and being covered by sediments. And also organic material being heated, either by pressure, volcanic heat, or chemical reaction heat. That's all it takes. Non-oxygenic conditions, so it can't combust, and the heat producing carbonization or coalification. Often you find the trees will go through different layers of coal. That's amazing. The evolutionists have to say that coal formed in the bottom of big swamps or peat bogs, and then the continent sank down and sediments laid on top of it, then the continent rose up, you have another peat bog for millions of years, and it sinks down and, sediment goes over that. All the while these trees are just standing there, they don't rot away, And these trees have no root system. You drain a peat bog, it's shot through with tree roots. You never find that in coal. Here we have an actual photograph of a polystratic tree trunk originating in coal. Notice the heat here, coalified even the bottom of the tree. It goes through layers of sediment and contacts another layer of coal up there at the top. So here we have a tree bridging what they would say is two different ages of coal formation. I don't think that their explanation makes sense. I think the flood gives a far more viable explanation. Huge massive vegetation ripped off these luxuriant continents at the time of the flood. As this began to get waterlogged and filtered down, it would be compressed, heated, turned into coal in a short time, and have polystratic trees associated with it as well. Oil also does not take millions of years to form. We have plenty of experiments now where they can get oil using biomass with heat and pressure and water. And 10 to 20 minutes, you've got crude oil, a process known as thermodepolymerization. This is used in certain plants, a turkey plant down in the south somewhere. They've got, the problem of what do you do with the turkey entrails and the turkey dung and the feathers and everything, with all the environmental rules. It costs a lot to dispose of that stuff. Well, they found if they just put it in big vats, adding water, they found water makes it work better. Others try to get rid of water. Well, if you've got plenty of water, heat and pressure, boom, you get oil in 10 to 20 minutes. Crude oil that they then sell and becomes a viable product. Well, nature could do that, for sure. In fact, if the oil price goes up much more, it might be competitive to turn a lot of our organic garbage into oil by the process of thermodepolymerization. Of course, during the flood, you had a lot of free energy around to do that. Catastrophic plate tectonics, global flood model of Earth history. This is a theoretical model, but it seems to have a lot of explanatory value, advocated by the following creationist scientists, especially Dr. John Baumgartner, a PhD in geophysics, formerly of the Sandia National Laboratories in New Mexico, currently with the Institute for Creation Research. He was commissioned to produce the world's most sophisticated and capable three-dimensional supercomputer model, to model Earth geology both on the surface and under the Earth simultaneously. And when he did that, he found that the old continental drift theory of slow separation of the continental plates didn't work. It only worked if it happened rapidly and catastrophically. And so he developed the rapid catastrophic plate tectonic theory, which starts with a supercontinent and a superocean, which the Bible seems to describe at the beginning. It says God separated the water from the land. He said that the waters be gathered together in one place and the dry land appear. It does sound like a superocean and a supercontinent to begin with. But with the cracking of the tectonic plates, you could then have movement floating on the mantle, so to speak, and gravity would come into play. Now, the oceanic plates are much denser and heavier than the continental plates. The continental plates tend to float higher and the others lower. But with these cracks, once they begin to fall under the force of gravity, this could be pulled toward this trench here, this toward this, because the crack in the middle, they would separate along the well-known mid-Atlantic trench. You'd have upflowing of magma, seafloor spreading, and a kind of a conveyor belt action going on there, which really helps explain why we have so much sediments on the continents and hardly any in the deep ocean. They've gone down with cameras along the mid-Atlantic ridge, looked at it, and says, they're rock. You have supposed to have been more than 100 millions of years of sediment going in there while these continents are separating. There should have been an awful lot of sediment there. But if they separated rapidly and recently, it makes perfect sense. We also have correlations between strata in North America and Europe, which seem to make sense that this broke up toward the end of the flood. I used to go into this in a lot of detail, but it gets a little bit technical. There's a lot of good information. This is good video or DVD on the subject, also at icr.org and answersfromgenesis.org. They have good free downloadable information on it that you can get at those sources. Now, there would have predictably been a post-flood ice age. Was there an ice age? Apparently, yes. A lot of physical evidence on the surface. Some of that, which they say is evidence of multiple ice ages in the geological record, we think is better explained by huge submarine landslides, which predictably would have to be happening during the flood. But the flood really is the key to explaining an ice age of any kind. Slight perturbations in the distance of the Earth to the Sun over time, that doesn't seem to be enough. You've got to have dramatic decrease in the summertime temperature, 40 degrees or more, so that snow that falls in the winter doesn't melt off during the summer, and it builds up and compacts in the glacial ice over time. Those little variations wouldn't do that. Even many evolutionists are saying, yeah, we need to have, a bunch of volcanoes go off and volcanic ash making things cold, or asteroid strikes kicking up dust to make things cold. Well, we believe, yeah, that happened during the flood, but the flood provides the key difference, and that is you need not just cold, you need warmth, because you've got to get the water out of the oceans onto the continents where it precipitates in terrific snowfall that compacts in the glacial ice. Even their supercomputers show if you get a bunch of dust in the atmosphere, yeah, the atmosphere gets cold, the continents get cold, but the ocean gets cold too. Cold water doesn't like to evaporate. So you get a cold age, but not an ice age. You get a real full-blown ice age. It takes the Genesis flood, because it predicts all this volcanic ash causing cold temperatures, but then extremely warm oceans, because of volcanic and tectonic activity on the ocean at the time of the flood, and thus you have this supercomputer just looks gnarly. Big, gnarly El Nino on steroids, just swirling over the continents with these big temperature differentials going on for at least 500 years, producing the greatest thicknesses of ice that we have physical evidence of, and doing it in a relatively short time. Now, because the breezes coming off the ocean are warm, the higher elevations would glaciate first, the tops of mountain ranges. That means there would be corridors down here for people to migrate. After the dispersion of nations of the Tower of Babel, you'd have several hundred feet lower sea level because of so much ice being trapped on the continents. And that means a lot of what now is shallow water would actually be dry land bridges, facilitating migration of both men and animals after the flood. Eventually, this corridor did apparently fill up, but men could still come across in boats. Of course, they descended from Noah, the great boat maker, and they could have come clear down the coast of North America, down into what is today the United States, even at that late date. Now, this excellent book is written actually for middle school students, but it's actually good for adults also, and it does a great job explaining how people in Northern Europe were living in caves, living a primitive lifestyle. But it doesn't mean they were cavemen or ape men. The movie with Tom Hanks, Castaway, shows you what happens to a 21st century college-educated businessman who gets stranded on an island all alone. He moved into a cave for shelter. He wasn't a carpenter, couldn't build a house, didn't have tools to build a house. He did the smart thing. Ready-made shelter in a cave, drew pictures on the wall like our ancestors did, and would make it more homey. He lived a very primitive lifestyle, not because he wasn't college-educated, but because once you lose your technology, it takes a long time to build it back up. These people lived a very hand-to-mouth existence of fear, a very primitive lifestyle like the Native American Indians did over 150 years ago. But they were certainly intelligent humans. Once the ice receded at the end of the Ice Age, these people came out and contributed with their intelligence to the building up of the great civilizations of Europe. And this book does a great job explaining that. The last part of the book explains how the meteorological conditions precipitated by the flood is by far the best explanation for an ice age. And here we have the Grand Canyon. How did it get there? It's huge. Many miles long, 4 to 18 miles wide, and about a mile deep. But what was it that produced it? Was it a little water in a long time, the standard interpretation, or a lot of water in a short time? Well, they say with the uplift of the Kaibab Plateau, supposedly 70 million years ago, and then we have all this erosion going on for 70 million years. But they did a major study where they compared over a quarter century, 25 years, to take in times of drought and good rainfall, average it together. They found out so much tons are eroded out of the Grand Canyon per year that if you multiply it by 70 million years, yes, you would erode the entire Grand Canyon, but you do so 1,500 times plus. You'd erode so much sediment if you spread it out over the whole state of California, it would cover the entire state 6 miles deep. So I don't think that that quite explains it. The fact that present rates of erosion, a little over 60,000 some years, would account for the Grand Canyon. Now, it would happen even faster if we had a catastrophic drainage event, and I think that is the best explanation. Notice here, the snow line tells a story. The Grand Canyon is a breach in a giant dam, the Kaibab uplift. So we have the little Colorado coming in over here at low elevation, 2,800 feet, no snow, comes through the Grand Canyon, exits here, transported there, sunk down, got buried in the bottom, much like we have a Specimen Ridge in Yellowstone Park. Well, you'd see this all over the world at the time of the flood. Forests being ripped off, the branches being broken off, and then ignite, but the heat drives off most elements except for carbon. Thus it carbonizes or coalifies the material. The brief hot heat will give you high-quality coal. Low-grade heat over a longer time will give you these things eventually coming to rest in an upright position and being covered by sediments. And also organic material being heated, either by pressure, volcanic heat, or chemical reaction heat. That's all. And with their scuba diving, they found a lot of these on the bottom of the lake. In fact, when they towed the sonar fish, they had found up to 20,000, they estimate, on the bottom of the lake. A whole forest there. It didn't grow there. It was catastrophically the lower-grade brown-type coal, but it certainly doesn't take millions of years. We also found many of these logs that begin to float upright after a while. Even though they're dead, they can absorb water from the root end and have buoyancy at the top and be heavier at the bottom.